Hello friends, welcome to the Physical Society, and today in this video we are going to discuss about numericals from F.C. Verma from the chapter Electric Field and Potential. So let us start with our first numerical, and the question here given is find the dimensional formula of epsilon naught. So let us start with the first question. So question here is demanding for the dimension of epsilon naught. So as you all know, electrostatic force may be written as 1 over 4 pi epsilon naught into Q1 Q2 over R square. So as you can see epsilon naught in the equation. So take epsilon naught to the left side and rest of the quantities in the right side. So F will be here and Q1 Q2 over R square. So substituting the dimensions of these quantities 1 over 4 pi. 4 pi is a dimensionless constant and the dimension of force is mLT minus 2 and dimension of charge is I into T. So substituting these we get and dimension of R is the length, that is the separation between two charges. So it is the length basically. So when we will solve this, m minus 1 L will be L1 power of L is here and the 2 powers of L are here. So after going above, this will be L raised to the power minus 3 and T raised to the power minus 2 is on the lower side. So when you will take it to the numerator, this will become T raised to the power 2 plus T raised to the power 2 is also above there. So T raised to the power 4 and I square. So the dimension of epsilon naught is m minus 1 L raised to the power minus 3 T raised to the power 4 and I square. So moving on to the next question. In this question we are told that a charge of 1 coulomb is placed at the top of your school building and another charge of 1 coulomb is placed on your house and the separation between them is given as 2 kilometers, or you may say 2 into 10 raised to the power 3 meters. We have to use SI units, so we may convert this into meters. So following this, we have to find the force acting between two charges. So the force will be F is equal to 9 into 10 raised to the power 9 into Q1 Q2 over R square. So the distance is 2 into 10 raised to the power 3 meter square of this quantity. So you will get F is equal to 9 into 10 raised to the power 9 over 4 into 10 raised to the power 6. And when you will divide this, you will get 4 when 9 divided by 4. You will get 2.25 into 10 raised to the power 3, or you may say 2250 newtons. Also, another question has been asked that how many times of your weight is this force. So you can solve this. Suppose you are having a mass of 70 kg or maybe 750 kg. Let us suppose we are 50 kg. So then our weight will be equal to 50 into 9.8 m into g. So solving this, you will get 490 newtons. So F over your weight. So the force acting was 2250 newtons over your weight. As you can see, this is approximately 49 into 2. So 225. So approximately 4 point something. 4.3. Again. So approximately this force is 4 times of your weight. And as you can see, these two charges are separated by a very large distance, 2 kilometers. Even then they are applying so much force on each other. So you can easily assume that the electrostatic force is very stronger than the gravitational force. In the next question, at what separation should two charges be placed so that the force between them equals a weight of 50 kg/cent? So, the force between them, so the force will be, electrostatic force will be K, Q1, Q2, and 1 coulomb. It means 1 square over U. We are asked about the separation. So, R square should be equal to 50 into 9.8. So solving this, we will get, take R square to the right and rest of the quantities to the left. The value of K is 9 into 10 raised to power 9, 1 by 4 pi epsilon naught. Basically, K is 1 by 4 pi epsilon naught. And the value of 1 square of 1 will be 1. And 50 into 9.8. We have solved in the last numerical. This will be 490. So 9 by 49. We may write this as, we may write 9 over 49. And 0 this 0 will go above, and this will be 10 raised to the power 8 R square. So applying under root over both sides, now you will get 3 over 7 into 10 raised to the power 4 should be equal to R. So you may say R should be equal to 3 over 7. So 0.422 and 8 into 10 raised to the power 4 meters. This will become R is equal to 4.28 into 10 raised to the power. Then this will be multiplied by 10, this will be divided by 10. So 1 power will be reduced. So 4.28 into 10 raised to the power 3 meters. Hence your question here is solved. So moving on to the next question. Two charges, equal charges are placed at a separate. It is similar to the last question, but in this case you are asked about the magnitude of the charges. Okay, suppose this is Q and this is also Q, and they are separated by a distance of 1 meter. So this, the force acting between them should be equal to mg. So 9 into 10 raised to power 9. Now we are using directly using the formula, because we are acquainted with the formula from the last questions. So charges we are asked, so this will be Q square Q1 Q2 over R square. 1 square should be equal to 50 into 9.8, and this will become Q square should be equal to 490 over 9 into 10 raised to the power 4. Q will become, and we will square root both sides, we will get 7 over 3 into, when you will take it above 10 raised to the power minus 9, and this is plus 1, 10 raised to the power minus 8, and this will be 10 raised to the power minus 4 after square root on both sides. Okay, so your answer will be this 7 by 3 into 10 raised to the power minus 4 coulombs. Or you may also write in the decimal form 3 to the 6, 1, 2.33 into 10 raised to the power minus 4 coulombs. The question is solved. So moving on to the next question. Find the electric force between two protons separated by a distance of 1 Fermi. So the separation between them is given and the charges. So their charges are protons. The charge on a proton is 1.6 into 10 raised to power minus 19 coulombs. This is also the same value because both are protons and the separation between them is 1 Fermi. And 1 Fermi is given as 10 raised to power minus 15 meter. So the force will be 9 into 10 raised to power 9 into 1.6 into 10 raised to power minus 19 square over distance between them is 10 raised to power minus 15 to the square of the distance. So the force will be 9 into 10 raised to power 9 into 2 point. The square of 16 is 256 and the point will be after 2 digits. So 10 raised to power minus 38 over 10 raised to power minus 30. And when you will solve this, 23.04 into 10 raised to power minus 29 and 10 raised to power minus 30 when we will take this in the numerator, this will become 10 raised to power plus 30. On further solving, we will get 23.04 into 10. So you may say the force acting is 230.4 Newton. So now moving on to the next question. So the two charges are given here, 2 coulombs and 2 microcoulombs and 1 microcoulomb, and they are separated by a distance of 10 centimeters. So suppose this is 2 microcoulombs and this second charge is 1 microcoulombs and the distance between them is 10 centimeters. So the question is asking where should we place a third charge so that it does not experience any force. Suppose we take a charge Q which is positive in nature or maybe negative, doesn't matter. So let us suppose we are placing this charge at a distance x from the larger charge and the remaining distance will be 10 minus x centimeter, or you may say 0.1 meter minus x. So now suppose the force acting this be F1. Let us this charge be first charge and this charge is our second charge. So first, and the force acting on the charge Q due to second charge is F2. These two forces should be equal so that net force may be 0. So F1 should be equal to F2. So this implies 1 over 4 pi epsilon naught into Q1 Q2, and the value of Q1 is 2 microcoulombs, that is 2 into 10 raised to power minus 6 coulomb. And the second charge is Q, and the distance between them is x square should be equal to 1 over 4 pi epsilon naught into 1 microcoulomb into 10 raised into Q over 0.1 minus x square. So as you can see, many of the things are common on the both sides, so we may cancel them. So you will also get cancelled, and raised to power minus 6 will also get cancelled. So the equation here becomes 0.1 minus x whole square should be equal to 2 is also here. So, and this is x square when it was multiplied. So taking square root on the both sides. So you may write root 2 into 0.1 minus x should be equal to x. So root 2 into 0.1. The root 2 is written as 1.414 into 0.1 minus x should be equal to x. So when we will solve this will become 0.14 minus 1.41x should be equal to x, and 0.14 should be equal to x plus 1.41x, and when you will add both of them in the right side you will get 2.41x. So x 2.41 will be there and 0.14 will be there, and the value of x will come out to be 0.059 meters, and so you may write it in centimeters as 5.9 centimeters. So our charge q is placed at a distance of 5.9 centimeters from the first charge, and the remaining distance will become 4.1 centimeters. Okay, so moving on to the next question. Suppose the second charge in the previous problem is minus. In this question, the situation is somewhat changed. So in this case, the first charge is 2 microcoulombs. The second charge is minus 1 microcoulomb. So when we will place a charge in between them, so suppose let us place a charge Q. So as this is a positive charge, it is also positive. So the charge Q will experience a force in the right direction. Also, this is negative and this is positive. This will also apply a force in this direction. It means this cannot be stable in between these two charges. So let us assume our charge is placed here. So this is our Q1 charge. This is our Q2 charge. The separation is still the same, 10 centimeters between both charges. Suppose this charge is placed at a distance of x centimeter from the smaller charge. So this is x, the total distance between Q1 and Q. The test charge will be 10 plus x, or you may say 0.1 plus x. When you will write it in meters, this will become 0.1 plus x. So F1 should be equal to F2. So 1 by 4 pi epsilon naught into 2 into 10 raised to power minus 6 into Q over R square. The distance between them is 0.1 plus x whole square should be equal to 1 by 4 pi epsilon naught into 1 into 10 raised to power minus 6 to Q over distance between them is x square. Following this, as you can see, many things are common here, they can be cancelled. Let's insert. So this will become 2x square should be equal to 0.1 plus x whole square. So when you will square root, apply square root on the both sides. So this will become root 2x should be equal to 0.1 plus x. So taking this left Taking this x to the left side, you will get x into root 2 minus 1. The value of root 2 is, as you all know, 1.414. So, we'll it here. This will become x is equal to 0.1 upon 1.41 minus 1. So the value of x will be 0.1 over 0.41. As you will divide this, you will get the answer x is equal to 0.241 meters. And when you will convert this into centimeters, you will get x is equal to 2.41 centimeters. So 24.1 centimeters. Okay. So let us move on to the next question. Question number 8. Two charged particles are placed at a distance of 1 centimeter apart, and what should be the minimum force between them? So the force to be minimum, smallest charge possible in the nature is charge on an electron or a proton. So the charges should be minimum. So separation between them is given 1 centimeter, or you may write 0.01 meters. So the force will be F is equal to 9 into 10 raised to the power 9 into 1.6 into 10 raised to the power minus 19 whole square over 0.01 square. So as we have multiplied this quantity many times before, this will be 23.04 into 10 raised to the power minus 29. From below, you will get 10 raised to the power minus 4. And when you will take this into the upper side, this will be 23.04 into 10 raised to the power minus 25. So the minimum force possible is 2.3. When you will divide this by 10, you have to multiply this by 10. This will be minus 24 meters. Okay. So moving on to the next question. Estimate the number of electrons in 100 grams of water. First of all, as you all know, if you know about the concept of mole, the molar mass of water is 18 grams per mole. Molar mass of H2O is 18 grams per mole. So we will get, as you all know, 1 mole consists 6.02 into 10 raised to the power 23 entities. So you may write number of molecules in 100 grams of H2O will be equal to 100 over 18. You will get from this number of moles, and into Avogadro number will get from this the number of molecules. As you can see, H2O, there are 2 electrons in the hydrogen and 8 electrons in the oxygen. So total number of electrons will be, the number of electrons will be this quantity multiplied by 10. When you will solve this, you will get the answer. I have made the calculations. First, question number 9, the calculation is 3.334 into 0.334 into 10 raised to power 25, and 1 power from 110 will be from this multiplication, because there are 10 electrons in each molecule. So you will get 3.34, and you will multiply by 10 into 10 raised to power 25 electrons. So the number of electrons are this much. Okay, this much electrons will be there in 100 grams. And how much is the total negative charge on these electrons? So charge on each electron is, so the total charge will be, as you all know, charge on an electron is 1.6 into 10 raised to power minus 19 coulombs. So this much electrons will contain this much charge. So you can easily multiply them and you will get the result 5.34. 5.34 into 10 raised to power 6. Okay, 6 coulomb. This is our final answer. Moving on to the next question. Suppose all the electrons in the last charge are clumped together and all nucleus are clumped together. So it means charge, as we all know, with grams of 5.34 into 10 raised to power 6 coulomb. From the last question, if these two charges are placed 10 centimeters apart, what will be the force between them? So we have to calculate the force. So formula for the force, K Q1 Q2. So Q1 is 5.34 into 10 raised to power 6 coulombs. Also Q2 is 10 but opposite in magnitude. So upon distance 0.1 meters square. When you will solve this, 9 into 5.34 square, this will become 2.256 actually. It will become 256 when multiplied, and when you will solve the power, there is 10 raised to power 9 and this will be 10 raised to power 12. 12 plus 9, 21. This is 10 raised to power 21, and from below, this is 0.1, it means 10 raised to power minus 1, and when we will square this, this will be 10 raised to power minus 2, and when this will go up, this will be 10 raised to power 2 positive. So when you will write in this form 2.56, this is divided by 100 and this is multiplied by 100. It means 10 raised to power 4 plus 1, this is 10 raised to power 25 newtons. So this is our final answer for this question. Moving on to the next question. Consider a gold nucleus to be a sphere of radius this much, and when two protons, let us suppose this is our nucleus, and when two protons are at their maximum separation, it means they are along the diameter. So the maximum separation will be 2 into 6.9, 2 into 6.9 fermi, and this will be 2 9 18, 2 6 12 and 1 13.8 fermi. This is 13.8 fermi. So we have to calculate the force. So the repulsive force will be 9 into 10 raised to power 9 into Q1 Q2, as you know, charge here is the charge on a proton. So both are protons, it means the square of this quantity over r square, and r here is 13.8 fermi, 10 raised to power minus 15 Newton. Then we'll spare this. So upper quantity we have multiplied many times, which will be 23.04 into 10 raised to power minus 29. And when you will solve the lower one, this will become 190.44. 190.44 into 10 raised to power minus 30. And when you will solve this, you will get 0.12 into 10 raised to power 1. So this will become 1.2 Newton. So in the last line you have been asked, why do these protons not fly apart from under this repulsion? When they are repelling each other, then why don't they leave the nucleus? So answer to this question is, as you know, there is a nuclear force acting between the protons and neutrons inside a nucleus. You may see there are many neutrons in every nucleus and many protons, but they are bound in this vicinity because of the nuclear force, because nuclear force is much stronger than the electrostatic force. Two insulating small spheres are rubbed against each other and placed 1 centimeter apart. If they attract each other with a force of 0.1 newtons, how many electrons were transferred? So you have been told about the force. Force should be equal to K U1 U2 over R square. And as you have been told about the force, substituting the value 0.1 newtons and value of K into Q1 Q2. Q1 Q2 are same. So Q square. Why these are same? Because when charges, suppose these two are the smaller spheres which have been rubbed against each other. So number of electrons which are moving from this to this, here it will be minus Ne charge, and here it will be plus Ne charge, because that much electrons are less in this. So the separation between them is 1 centimeter. So you may say 10 raised to power minus 2 meter squared. So you will get the 0.1 into 10 raised to power minus 4, when you will cross multiply them, and 9 into 10 raised to power 9 Q squared. So 10 raised to power minus 5 1 over 9 into 10 raised to power minus 9 equal to Q squared. We will solve this further. This will be 1 over 9 into 10 raised to power minus 14 should be equal to Q squared. So when you will square root both sides, you will get Q is equal to 1 over 3 into 10 raised to power minus 7. Or you may say Q is equal to 0.333 into 10 raised to power minus 7. Or you may also write this like 3.33 into 10 raised to power. When you will multiply by 10, this will be divided by 10. So this much coulombs of charge has been transferred from one sphere to another. And for this much charge, how much electrons will have moved from one sphere to another? So answer will be n number of electrons should be equal to the charge that has moved 3.33 into 10 raised to power minus 8 divided by charge on a single electron, that is 1.6 into 10 raised to power minus 9. So n will be equal to, when you will divide this, you will get 2.06. This will be 2.06 into 10 raised to power 11. So this much number of electrons have to be transferred to gain this much charge. So let us move on to this next question. NaCl molecule is bound to the electric force. So suppose this is our Na1 positive and this is our Cl1 negative, and these two are separated by a distance of 2.75 into 10 raised to power minus 10 meters. In question you have been given minus 8 centimeters. So when you will convert this into meters, you have to divide this by 100. So you have been asked to find the force between them. So F will be 9 into 10 raised to power 9 into charges. The two charges are 1.6 into 10 raised to power minus 19, because one electron is less and one electron is more in the another ion. So the distance between them is 2.75 into 10 raised to power minus 10 and the square of this. So you will get F should be equal to, on the upper side, as you all know, we have done this many times, it was minus 29, and on the lower side when you will square 2.75 you will get 7.56 into 10 raised to power minus 20. And when you will further solve this, you will get the answer 3.04 into 10 raised to power minus 9 newtons. So this much force acts between Na1 positive and Cl1 negative ion. So in the question you have also been asked that state the assumptions, if any. If you have made any assumptions while solving the limit. Suppose this is an ion, Na1 positive, and this is Cl1. So as you can see from your prior knowledge, the electrons revolve around the nucleus. Suppose this is nucleus and this is the orbit. So extra electrons will also revolve, but we are assuming that these extra electrons, or you may say these lack of electrons, so they are stable in their position. So this is the assumption that we have made while solving our numerical. Moving on to the next question. Find the ratio of electric and gravitational forces between two protons. So we have to find force electrostatic over force gravitational. As you may say, force electrostatic force acting between two protons is kq square over r square. Let r be the separation between them. Then g mass of the proton square over r square. R square is same on both cases, so we may cancel out r square. So the value of k is 9 into 10 raised to power 9, and charge on a proton is 1.6 into 10 raised to power minus 19, and when you will square this over value of g is 6.67 into 10 raised to power minus 11 into mass of a proton. Mass of a proton is 1.67 into 10 raised to power minus 27 kg. This square. When you will solve this, on the upper side, you know this will be 23.04 into 10 raised to power minus 29. On the numerator, in the denominator, you will get 18.60. 18.60 into 10 raised to power minus 11, and this is minus 27 squared, and this will become minus 54 plus 11. This will be 10 raised to power minus 65. So when you will divide this, you will get 1.23 into 10 raised to power minus plus, because this 65 will, when this will go on the numerator, this will be positive. 10 raised to power 36 plus 36. So you can see that electrostatic force electrostatic acting between two protons is 1.23 into 10 raised to power 36 times of the F gravitational. It means electrostatic forces are very strong in nature. So moving on to the next question. Suppose the attractive force acts between the two protons, which may be written as this. Write down the dimensional formula and appropriate SI units. This question is incomplete, so let us complete this question. SI units of C and K. And in the second part, you have been asked, suppose we are given the value of K is 1 Fermi inverse, then so one thing is also given here. The separation between them is to be supposed 5 Fermi. 5 Fermi, R is given 5 Fermi. Then find the value of C. Find the value of C. Now let us solve this question. So as you can see, F is given, nuclear force is given in the form of C e to the power minus k r upon r square. So e to the power minus something, e to the power anything is always a numerical value and does not have any dimension. So dimension of C will be F into r square. So dimension of force is mlt minus 2 into L square. This will be ml3t minus 2. Also the unit, you can find unit from here. SI unit of C will be, force is in newtons, R is in meters, so Newton meter square. E to the power minus anything, this should be a number. So minus kr should be equal to what? 1. Kr sign doesn't matter here. So k, dimension of k should be equal to 1 upon r. So k is the length, r is the length, so 1 over n. So dimension of k is equal to L inverse. And its SI unit will be meter inverse. Meter inverse. So let us solve the second part of this question. Let us rub this first. So let us solve the second part. For the second part, we have to find the value of C and the force. We are told that the nuclear force is equal to electrostatic force. So when two protons are separated by a distance of 5 Fermi, the electrostatic force will be 9 into 10 raised to power 9 into 1.6 into 10 raised to power minus 19 squared over distance between them given is 5 Fermis. 5 into 10 raised to power minus 15 squared should be equal to C e to the power minus k. K, the value of k given here is Fermi inverse. So 1 Fermi inverse into r. Value of r is 5 Fermi. So over r square. So 5 Fermi square, 5 into 10 raised to power minus 15 squared. So Fermi inverse will get cancelled with the Fermi. So and also 5 into 10 raised to power minus 15 square is common on both sides, so you may cancel this. So this will become P should be equal to 9, and you have solved this many times. You may write this 23.04 into 10 raised to power minus 29, and this E will be here e to the power minus 5. As you can see, minus 5 will be here. So value of C is equal to 23.04 into 10 raised to power minus 29 into e to the power 5. So this will be on the upper side in the numerator. So when you will solve this, you can check the value of e to the power from the exponential table, or you may go to the internet for this value. You may Google this. The value of e to the power 5. This will be 148.41. 148.41. So 23.04 into 10 raised to power minus 29. And this value will be 3.4 into 10 raised to power minus 26 Newton meters square. As you know, we have derived its unit in the first part. Thanks for watching our video, and thanks for giving your valuable time to us. Please like, share and subscribe our channel. It will be a humble attitude of you for us. Again, lot of thanks to everyone who have watched this video completely. And please, before starting any question, just try it with your own mind. Thanks again.